Dear students, Assalamu alaikum. Welcome to the second program on Software Engineering 1. In the first program, we define what is software. We also explain how a software as a product is different from other products which we engineer. We also explain what do we mean by a well-engineered software. And with the help of an example, we explain why do we need to engineer the software. In today's lecture, we will define what is software engineering. We'll explain what do we mean by a process and a software life cycle. We'll also outline the characteristics of a good software process. And in the end, we'll present some commonly used software processes, their weaknesses and strengths. To start with, we will define software engineering. Dear students, there is not just one definition of software. Different people have defined the software in their own views. There are many different definitions that have been proposed in the literature. But we are going to see two such definitions. The first definition is software engineering is the application of a systematic, disciplined, and quantifiable approach to the development, operation, and maintenance of software. That is, application of engineering principles to software. This is the definition given by IEEE. The second definition taken from the Pressman book is software engineering is a discipline that integrates methods, tools, and procedures for the development of computer software. Dear students, when we look at these two definitions, we note few points which you should keep in your mind. These points are: the software engineering involves application of systematic, disciplined, and quantifiable approaches. Just like any other discipline, engineering discipline, we have to use an approach which is systematic and which can be quantified. That means we should be able to judge numerically how good that approach is, how good is the product which is developed using that approach. Another important point is the software engineering recognizing technical, managerial, and social technical issues. That's a very important point to note. Software engineering is not writing code. It is more than writing a code. A software engineer, yes, he has to be a very good programmer, a good designer, but he should also possess the managerial skills, and he should be aware of the social and other technical issues, because ultimately the software is to be used by the people. So he should have how the people behave and how the people react to their products. Another important point is software engineering is multidisciplinary. It involves the knowledge from mathematics, management theory, engineering sciences, and social sciences, and many other disciplines. Now, when the computers are being used in almost every field of our daily life, we have to make the computers work everywhere in all the disciplines. So the software developer should possess the basic knowledge of different fields. Sometimes the people from different fields come together on a software project so that they can develop an effective project. The fourth very important point which is to be noted from the Pressman definition is that software engineering is a layered technology. As we can see from this figure, that in the software technology, the the foundation is the quality focus. As we have discussed in our first program, it is the quality we should be striving for, because software as a product has to be sold in the market, and now the customer look for the quality. So if you want to develop a good quality software, we need a commitment both at the developers level and at the management level, a commitment to the quality. They should not be compromising on the quality, whether it's the quality of the product or quality of the process which is used to create the product. On that foundation, then the next layer is the process model. The process is the basic techniques, the basic steps, the activities we have to carry out to develop a good quality software. The next, the methods. Dear students, we shortly discuss the process in more detail, but at this time it is enough to say that when you are using a process which defines the activities, that if you want to create a good quality software, you have to do this, this, and that. But a process model generally doesn't say how to do it. You need the methods. For example, a process can say that if you want to develop a software, you have to do the analysis. But what techniques and methods are used to do an effective analysis are required. So we have to look for the effective methods to carry out those activities. At the top of the hierarchy is the tools. Now software is becoming very complicated to write. We are developing very huge projects. Therefore, there is a need to automate some of the activities during the software development process. So we need some tools as well, which can help us to carry out those activities that will also help us to produce a quality software. Dear students, we just use the word process. So let's discuss the process in little more detail and see what we really mean by process. Generally, a process is a series of steps to produce an intended output. This is a very generalized definition of a process. Whenever you want to build something, you have to build that thing following certain steps. Even if you want to make a dish, there are some steps which need to be followed. So process basically defines those steps which you should be carrying out to develop any product. When we use a process for building a software product, it is called software life cycle or software process. Of course, these two words, software life cycle and software process, they have just been used to distinguish it from a generalized word of a process. So when we say the word software life cycle, then we really mean that those activities which have to be carried out to develop a quality software. Now the question is, do we really need a process to develop a software? Because we have been writing the software and sometimes without following any elaborate process. Now if you remember our example of building a doghouse, then you realize, yes, if you're writing a small piece of software, you might not need a very elaborate process. But when you're writing a complex and huge software, a very elaborate process is required. Whatever process we use for developing the software, you would notice that all the processes have some common activities. These are the activities which every software developer has to do to develop a good quality software. These common process activities are software specification. Dear students, software is written to satisfy the requirement of the user. Therefore, the first step is always go to the user and ask him what really the software should be doing for them. You have to collect their requirements. Without the requirements, you cannot write a software. The second activity is software development. Once we know the user requirements, of course, the next step is now to design the software and using some tools, develop the software, writing the code, testing the code, and writing the documentation. So software development is the next step which we have to carry out in developing a software. The next step is software validation. By validation, we simply mean that once the software has been developed, we have to make sure the software has been developed according to the specification. If the software has not been developed according to the specification, of course, it's a useless software. So making sure that software has no bugs and it has been developed according to the user requirements. Once that's done, the software is ready, it is delivered to the user. But we know once the software is delivered to the user, we cannot expect that the user requirements are not going to change. So another important common activity is software evolution, which simply means that when the new requirements come, we have to accommodate those requirements into our software. We have to make sure that our software satisfies the user requirement throughout the lifetime. Dear students, these are the 4 common activities of all the software development processes. But there are some more activities which do not fit exactly into these 4. But these other activities are carried out throughout the software development process. Generally, these activities are known as umbrella activities. Briefly, these activities are software project tracking and control, software quality assurance, software configuration management, document preparation and production, reusability management, measurement, and the risk management. At this time, we are not going to discuss these umbrella activities in detail, but in the coming lecture, we'll be touching upon these points in more detail. Dear students, we just said that to develop a good quality product, you have to use a process model. Of course, there are 2 different ways of judging the quality of a product. Either you see the product itself and then find out whether the desired attributes are present in that product or not. The second approach, which is now advocated by relevant ISO standards and CMM, is not to look at the product, but to look at the process itself, the process which has been used to create that product. The idea is that if you use a good process, it will create a good quality product. Not only that, using a process enables you to accommodate, to improve your experiences, to improve the process models to develop the new products. Dear students, there have been a lot of process models which have been proposed in the literature. The question is, if you want to develop a software, which process model to use? Of course, when you have a lot of options, you have to weigh which model has better characteristics. We have discussed the attributes of a good quality software. Similarly, a good process has some characteristics which are very important. So the process characteristics which are very important for the comparative study of different process models are understandability. A model should be understandable. All the activities which are defined by that model should be understandable, they should be clearly explained. Of course, if you do not understand a model, how can you apply it? So a good model is easy to understand. Another important characteristic of a good process model is visibility. A visibility simply means that a process model accumulates the artifacts as we move along the process. After some steps, when they are carried out, we have something tangible so that we can measure the progress. A good process model should be visible. We should be able to see that how much progress has been made and how much work is left. Another important characteristic of a good model is supportability. A good model should have some case tools which can support us in carrying out some of the activities. So when we are selecting a model for the development of a certain product, we should be looking for whether or not the support tools are available or not. If the support tools are available, they can improve our efficiency. They can improve the quality of the product. Another important characteristic is acceptability. We have many models which are technically very strong. They are very good models, but they are rarely used by the practitioners. For some reasons, people don't like those models. They do not have the confidence in those models. They believe that these models, even though they are good, but they cannot produce a good quality product. So a good process model should be acceptable to the practitioners, which are ultimately the user of the process models. Another important characteristic is the reliability of the model. That means when you use a model, you should have the confidence in it. You should have the confidence that using that model, you will be able to produce a good quality product. It should be reliable. Another important characteristic is robustness. A process model should have some built-in features which can deal with the unseen circumstances. It should be robust. We should be able to improve it. We should be able to mold it according to our requirements. Another important characteristic is maintainability of the process model. One of the reasons for using the process is that people get experience. So if a model is flexible enough, then we can make the changes in that model which can better suit our requirements. Dear students, we have discussed that to develop a high quality software, you have to use some kind of process model. We also outlined some of the characteristics of the software process models. Now let's discuss some of the process models which have been proposed and see how those process models really work. We'll also be looking at their weaknesses and the strengths so that you can make an informed judgment on the selection of a process model when you are going to develop a software. The first model we want to discuss is called the waterfall model, as you can see on this diagram. The waterfall model is the model which has been used for a very long time. Presumably, this is the oldest model. This is the first model which recognizes the fact that a better software can be developed in phases. Therefore, in this model, the software development has been divided into distinct phases. These phases are: the first phase is the requirements definition. The second phase is software design. The third, implementation and unit testing. The fourth one is integration and system testing. And the last one is operation and maintenance. During the first phase of requirement definition, we basically go to the customer and ask for their requirements. So our emphasis is to know what really they want, what services the software should be providing to them, what type of information our software will be producing, which is useful for them. During the second phase of the software development model, we design the system. We design a software. Designing the software involves designing the user interfaces, designing the software architecture, designing the software interfaces, and many other things. During the third phase of implementation and unit testing, the software is developed in small modules. Each module is developed independently, and once each module has been developed, it is tested to make sure that it works, and it works according to the requirements, and there are no bugs in that unit. During the fourth phase of the waterfall model, which is integration and system testing, we bring all those components together to make one working product. But once those components are brought together, we have to again make sure that those components correctly work together. Yes, they will be working, or they are working correctly when they are executed independently. But it doesn't guarantee that when two components are put together, they will work properly. So we have to make sure that the system as a whole works according to the user requirements. Once a system has been tested, it is delivered to the user and it is put into use. Once the system is used, as we have emphasized this point many times, that software is not a static entity, it is dynamic. We have to accommodate for the new changes. That's what we call the maintenance phase. During the maintenance phase, new changes can come in. When those changes come, then we have to follow the steps of the waterfall model again so that our software keeps working as per user requirements. Dear students, this model, though it's very simple, has many good points as well as some weak points. So let's look at some of the strengths of this model. The first is simple to implement and manage. The second good point about this model is that it's well understood and widely used. And the third plus point is that it imposes a disciplined software development approach that requires documentation to be produced at each phase. Dear students, if you just compare these plus points of the waterfall model with the outline of a good process model we have just discussed, then you will feel that the waterfall model has many good points in it. It is very visible because it enforces the software developer to produce some tangible product at the end of each phase. Similarly, there are some weaknesses of that model. So let's have a look at some of the weaknesses of waterfall model. Organizations use different names for different phases. Of course, we have used some terminology for different phases, but that's not the only terminology which is used in waterfall model. For example, we use the word system design or the software design. Some people just use the word design. We use the word requirement analysis. Some people call it requirement engineering. Some people call it system analysis. So there are different words, different terminologies which are used for different phases of the waterfall model. Of course, these different terminologies create some confusion, but of course they are not significant. What's important to know is what we really do in each phase and what is the output of each phase. The next weak point of this model is real projects rarely follow the sequential flow proposed by this model. Dear students, this model imposes that the software is developed in a linear sequence. First you collect the requirements, then you design the system, you develop it, you test it, and you deliver the system. Unfortunately, the real software projects are not developed like that. Users generally do not know their requirement at the start of the project. But this model imposes that once you complete the first phase and move to the next phase, you cannot go back to the first phase. So if the new requirements are coming at a later stage, they will be very difficult to accommodate. First, you have to develop a complete product, deliver it, and then go back and restart accommodating the new requirements. Another weak point of this model is all requirements must be known at the beginning. That's what we just said. Another point is that a working version is not available until late in the project time span. Dear students, you might have noticed in the diagram that a working product, the software, is delivered to the user at the end of the project. You might not have the final product for years. This makes the user frustrated. Another negative point of this model is undetected blunders may lead to disaster. Now, if you make a mistake in the requirements or in the design, and you are unable to discover those mistakes, and those mistakes slipped into the final product, then you will have a complete failure. There is no point going back, and even if you go back and make the correction in your software, it's very costly. Generally, it is believed that if you can correct a mistake at the analysis phase, and if that mistake is not detected and not corrected at that stage, and it slips into the final stage when the product has been developed and delivered, then it can cost you up to 1,000 times more. That's a complete disaster. Another point about the waterfall model is it's not suitable for large projects. Of course, we have seen that once we use the software process model, the waterfall model, the final product is available at the end of the phase, at the end of the final phase. Therefore, the people get frustrated. They don't see anything in their hand, especially the user who wants to see a working product in front of them. Second, because if an error slips from the early stages into the final stages, that can be very disaster. So for a big project, this model generally believed not to be a very good choice. Dear students, in today's program, we defined what is software engineering. We outlined what is a process and what is the process life cycle. We also outlined the characteristics of a good software process model, and we explain why we need a process to develop a high quality software. We presented to you one of the software process model known as waterfall model. Dear students, there are many more models to be discussed. We'll continue discussing the software development models in the next program. Thank you very much. Allah Hafiz.